Hello, my name is Carl Hoff. I'd like to talk to you about my latest packing puzzle. It's actually a sequel to the puzzle that I presented at G4G15. It was created by searching a 21-piece subset of the hexominoes. Of those 21-piece subset, there was only a single 9-piece subset that had a unique solution on an 11 by 11 board. All other of the searched 9-piece subsets had more than one solution. There were no sets with zero solutions. It's also, I should point out that Mr. Puzzle and Chris Ramsey have both made very nice videos about this puzzle on YouTube. It's sort of interesting that it's one of the few Chris Ramsey videos that I've seen where he was actually unable to solve the puzzle. I ended my last talk with two open hypotheses. Based on the searches that I had done at the time, which was pretty much all I could do with the software I had available with me at the time, was I made the guess that that 9-piece subset was the only 9-piece subset to have a unique solution, and that all other 9-piece subsets had multiple solutions. There's sort of a bold claim at the time because of the more than 70 million 9-piece subsets you can make from the 35 hexominoes. I'd only searched a bit under 300,000, which is less than 0.5%. I now have code that allows me to search the full space of all the hexominoes, and I have now done that. It took the new code I've got a bit over 82 days to do that, or 0.1 second per subset. It found 16 subsets with fewer than 10 solutions, and Hazmat Cargo was indeed the only set that had a unique solution. However, there were 3 sets that had no solutions. All of them contained piece 21 on it, or piece 26 on that table, which wasn't included in the original 21-piece subset that was searched. So where do I go from here? I want to make an even more difficult puzzle. I'm that type of puzzle designer. So I decided to let's see if we can make a 9-piece puzzle using the heptominoes on a 12 by 12 board. Looking at all 9-piece subsets of the 108 heptominoes was a bit much for my code still. So I wanted to look at a subset of the heptominoes, and I picked the non-compact, non-symmetric heptominoes. I imagine everybody in this crowd knows what non-symmetric means, but non-compact is basically my way of saying that the heptomino has the maximum perimeter possible for its bounding box. So these are all either 2 by 8, 3 by 5, or 4 by 4. Basically trying to pick out the pieces that are difficult to pack. So of that, I searched all 52 million possible 9-piece subsets. I found 8 sets that had unique solutions. There were 101 sets with no solutions, and then all the others had multiple solutions. This is a table I made of some of the properties for the 18 solutions that I found, or sets with unique solutions, and I'm comparing them to the original Hazmat Cargo. The first one is the one I ended up naming Hazmat Cargo 2 for a couple reasons. If you look at the solution time for my code, the original Hazmat Cargo it could solve in 512 seconds, or about 9 minutes. The Hazmat Cargo 2, it takes my program over 5 hours, about 5 hours and 40 minutes to completely search the search space. All the other solutions were in the ballpark of about an hour and a half. Why that one's so different from the others is rather interesting. I also counted the number of near solutions each set had. And that first solution had 62,226 near solutions, i.e. solutions where you have a single corner touch. All the others were under 10,000. There's one set in there that's got as few as 360 near solutions. I also counted what I called dead corners. Dead corners are corners that are not touched in any of the near solution states for the puzzle. So basically every corner in Hazmat Cargo 2 that can be touched in a near solution is touched in one of the near solutions. There's only one other of the 18 sets here that had that property. But anyway, I picked the first one to be my puzzle, and those are the 9 pieces. So I've given everybody a copy of this piece, basically a paper on that, as my exchange gift, but your goal is to take those 9 pieces, pack them on the 12 by 12 board such that no 2 pieces touch. My guess is it's probably going to take most of you a computer program to do that at this point. I know somebody gave a talk on the first day saying that the ideal number of pieces for a polyomino packing puzzle is the golden region is between 9 and 15. Well, if you play with this one, you're going to think 9 is too much. Anyway, that's my talk. I'm primarily known for twisty puzzles. I also make puzzle rings and some other puzzles. My topic last year was on the double circle reel 6x6x6, which I brought with me. It's basically the functional equivalent of a 2x2x2 inside of a 4x4x4, all inside of a 6x6x6. If anybody's interested in taking a look at that, it's at my table over there. But that's my talk. Thank you very much.